So let's start. Here I want to find the area bounded by f of x equals x squared plus 1 and y equals 0 for negative 1 is less than or equal to x is less than or equal to 3. So this piece right here, this inequality, is really giving us an interval. We're saying between negative 1 and 3. It's just a different way to write it. So I know that a is negative 1. I know that b is 3. I'm going to start by graphing this function. So here, let's see, x squared plus 1, negative 1 to positive 3. Let's see, my function right here, x squared plus 1. So let's see, here is what my function looks like. And already, I think we're going to have some oh, no, you know what? I drew negative x squared plus 1. I want positive x squared plus 1. There we go. That's a little bit better. Double check your graphs, ladies and gentlemen. So, all right, I want the area bound by my function f of x and the x-axis between negative 1, so here's negative 1, to positive 3. I want to know what is this area right here. So in this case, it doesn't look like there's any intersections between my function and the x-axis, which is good. That works out well for me. So when I set this up, I'm going to set this up as the definite integral from negative 1 to positive 3. In this case, my upper curve, that is the parabola. That is x squared plus 1. So sometimes it'll help, I'll try and do this, to label your functions. This is x squared plus 1. So my upper function is x squared plus 1 minus my lower function. My lower function is just y equals 0. That's the x-axis. That's this piece right here, y equals 0. So I want to subtract 0, and then I'll integrate with respect to x. So I'm just trying to evaluate this definite integral. So if you can, first thing you want to do is simplify anything, combine like terms, distribute negative signs, things like that. Here we're just subtracting 0, so we can really just drop the 0. We can say the definite integral from negative 1 to 3 of x squared plus 1 dx. And we can just integrate this. So let's find our antiderivative. So our antiderivative, we should have x cubed over 3 plus x, and I'd like to evaluate that at 3 and negative 1. So let's see, I should have 3 to the third divided by 3 plus 3 minus negative 1 to the third over 3 plus negative 1. So let's see, 3 to the third over 3. 3 to the third would be 27. Divided by 3 there I have 9 plus 3 minus here negative 1 to the third will be still negative 1 over 3 plus negative 1. And then we're just simplifying this. So let's see, 9 plus 3, I've got 12. Minus here, negative 1 plus, or excuse me, negative 1/3 plus negative 1. I should have negative 4/3. So let's see if I wanted a common denominator. Well, first of all, let's do this. Minus negative plus a positive. 12 times 3, that would be 36 over 3 plus 4 over 3. The area bound by those two curves is 40 over 3. So here is the area bound by those two functions. So be careful here with these. You will definitely want to draw a picture of your two curves and kind of sketch in that area. Make sure you know exactly what area we are talking about here. This is probably the one instance I would say a graphing calculator would probably be helpful. If you want to use your graphing calculator to help you visualize these spaces, that's perfectly fine. But even if you don't have one, I think we can still get the general idea of these graphs across.